All right, welcome back to Lag Demon Programming. In this video, we're going to continue on with our Rusty Mud project, and what we're going to do is add in a database. It's a simple embedded NoSQL database. It's a Rust package. It's nice and easy to use and simple. And yeah, it's called Reindeer, and we're going to plug that in and start saving our user accounts to a database so that we can retrieve them and start validating them. Thanks for watching. Let's get to it. All right, so in the previous video, we got some things working with email verification, passwords, and so forth, and we started setting up a player account. Now, what we're going to do today is we're gonna flesh this out a little bit more and change it a little bit, but we're also going to bring into play some additional tools, and one of those things is on crates.io. And we'll take a look at it here on crates.io. And what we're going to be looking at is Reindeer. So Reindeer is a small entity-based embedded database with a minimal NoSQL relational model written in pure Rust. So this is a really nifty little database, and we're going to use it to store our information. We're also going to use a couple other packages, and I'll show them to you. But Reindeer is really slick, and so this is the version that we're going to use here. And so let's get into setting some things up for that, and I'll explain it kind of as we go along here. So we've already got some things included. Let me take a look at the using statement up here. So we've got all of that. Yep. So what we need is a couple of things. So I'm going to go in here. I'm in the Rusty Mud Common. I'm going to go into cargo.toml. And let me see what I need over here. Go that. Just check my notes here. So we've got all this. So we need to bring in several packages, and I'll explain these. We've already talked about bringing in packages, so let me go ahead and put these in, and I'll talk about them a little bit. So here's Reindeer. That's going to be our database. We're also going to use UUID, which is going to allow us to uniquely identify objects in our database. We'll use that as the ID. Handlebars, we're going to get to that. Handlebars is another interesting package for working with templates, which we're going to need for emails, and then we're going to need the random package as things progress along here. And we'll get into exactly how those work and what those do. First thing we're going to start working with is our database, and I'm not sure why this is. Why is this here? And oh, I had it open. So let me get rid of these. I had that open when I switched branches on Git. So I'm keeping all my prep work in another branch. Okay, so here's our player, and we can go back to here and find it here. There's that, and here's player. Okay, good. So we need to use some things. Specifically, we need these. So we're going to bring in the UUID package, which will allow us to create some unique identifiers. We're going to bring in Reindeer. Now, serialize and deserialize are actually part of SERDI, the serialization deserialization package, but they're re-exported from Reindeer, which just makes it really convenient to use these right from Reindeer. And I'll explain a little bit more about that later. And then directories will let us get platform independent directories. So if you're on Windows and you ask for like the user home directory, you'll get the Windows user home directory. If you're on Linux, it'll return the Linux user home directory and so forth. And the same for projectors and base directories and so forth. everything here is good with the email and the password. So when we create a password, we're hashing it and checking it for its validity. We already went over that. So here in the player account, this is what we're going to beef up a little bit. So I'm going to create an enumeration here for roles. And I don't believe I did player roles, right? No. So that we have a variety of roles. We have an owner, an admin, a moderator, a player, and disabled. So if we disable an account, we'll simply assign it that role, and it'll be disabled. They won't be able to log in. We'll go over that as we get to those kinds of things that we're going to do. And then we're going to change this player structure here a little bit, and we're going to have to change some of the methods associated with it that we did before. So let me put this in here. We're going to have an ID that's a string. This will actually contain a UUID, and we'll be able to transfer that back and forth. We'll give a nickname, which is what people will see on the screen. We'll have an email, their password, a role, and a token. The token is optional. That way it can be removed, but the token is what we'll use to validate the email. So the system will, when a person creates an account, the system will send an email. It'll contain a token, a random set of characters and numbers, and they'll have to plug that back in order to validate their email. Actually verify their email account rather than validation is checking that it's in proper form, and verification is checking that the person actually owns it. So now we need to set this up. So ID is going to be we're not going to pass in the ID at all when we create a new one of these. What we're going to do here is say UUID : new v4, new underscore v4. So it's just going to automatically create that. We'll pass in the email and the password for processing, which will become, so you know what we're going to do? We're going to change this around a little bit. So let me move this down like this so this is more readable. We're going to pass in the password as a string. As an ampersand string, as a reference to a string. We're going to also pass in, so when they create the initial account, we've got their email isn't going to be an email, it's also going to be an ampersand string. And we'll do the initial processing here when we create the account. We'll have a default role, will be player, role : player roles, not admin, player. And we'll generate a token. And we'll get to that in a minute. For the moment, we're going to go token : none. So that's when we create an account. Now, to do the email, this is the wrong type. We're going to need to create the email. So we're going to go email : process email. And we're going to go password new password. Okay, so initially it'll be the new password process is up here. Email, where's password? Password new, puts it through this process of verifying and validating and all that. So we'll process the password there, and that will create an account. I think that's how I did it. Let me double check. Player account, UID. Oh, we've got to go new v4 dot toString. We need to turn that into a string. Email dot to owned, we need to pull that in to an owned value for the email process to work. Password also needs to be to owned. And then we're going to set, oh, we didn't do a nickname. We need a nickname up here. Ampersand. And then we need to pass in the nickname. Role, and then nickname colon nickname dot to owned again. Okay, so what does this mean? So this ampersand string is a reference to a string fragment. This just makes it a lot easier to pass stuff into here rather than passing in strings, which are owned things. But we're going to snag it and create an owned string out of it and apply it to this. And that will leave that original reference alone because it'll make a copy of it down here for going into this, so that when we create the account, everything will work out very nicely. Then we've got some things that we need to do in here. But this has to do with initializing and setting up our database. So we've got the database installed up here. What we need to do first is create some functions to assist us with the database. This isn't that big a deal. So here in this, I'm going to create another file, new file called database.rs. And this creates a module again. We've talked about that a little bit before. Player is a module. Now database is a module. We need to go in here into live.rs and put pub mod database. So that exposes our database module to the rest of the world here. So we're going to pull in some using statements. Actually, you know what? I'm just going to copy this whole thing into here, and then I'll describe it rather than typing it, because this is kind of long, and this could go a little bit long if I type it all out. This is pretty straightforward, so I'll explain it. So we're going to bring reindeer into scope. Its database object, error and error kind. These will be used in our handling of it. We're going to bring in directories and specifically user directories, because we're going to use the user home directory to store data in a special path. And then we're going to bring in standard path and path buff so that we can work with these paths. And then we're going to use the crate, our crate. So crate is the module that is the whole package level, crate level object. This says our entire crate. In there is the player module and player account. This is a complete, absolute path to our player account module. And this allows us to get access to player account. We're going to have access in here to a variety of other accounts as well. And I'm not sure if, did I actually ever use this? We probably don't actually need this. I think that's an artifact from a previous attempt at something. So what does this do? So database dir returns a path buff, and what we're looking for here is under user dirs. We want to create a new user dirs object so that we can get access to it, and this returns an option, so we need to match on the option. And so when we match on user dirs, if there's some user dirs, we can access it, dir, and we want the home dir, which is the platform specific home directory for the user based on the platform. And we want to join to that the path.rustymud_db. So what this will do is in the user's home dir, it'll create the folder .rustymuddb. And under there is where we will store all our database files. And if it's none, we're just going to, if for some reason we can't get this object, which I think would be very unusual, we're going to go ahead and create a path anyway, but it's going to be right in the current directory. // to owned is where we're going to save things. And actually, we should change this. I'm going to make a little modification here. We'll do it in the current directory, but what we'll do is we'll do that. So it'll be just a .rustymud db directory in the current directory if for some reason this object doesn't come back. And then we've got a function here to open the database. And this returns an option of our database object. And so we're going to match on reindeer.open and that path database dir. So whatever this returns is our database dir, and it's going to open the database on that. If that comes back okay, we're just going to return some DB. If it comes back as an error, we're going to return none. So I'm just getting rid of the error condition here. We'll handle that later. Handling errors and passing them back and so forth is very important. What I probably should do here is print the error out or something, but for now, I'll just return none. We can handle the error later if it can't create it for some reason. But if it's okay, then we're just going to return the option sum and the database. Okay, so that's taken care of. Now, there is a tricky little thing that we have to do with the database here. And that has to do with initializing. So when we create our player account here, we're going to actually, let's go back to players and find here's our player account. We actually have to derive some things on this, and we've already got debug, so we need some additional ones here that I'm going to put in place. Okay, so the serialize and deserialize is going to set us up with certain capabilities in this thing, and specifically what we're going to do is implement this as a database entity. Okay. So it needs to be serializable and deserializable so it can the system can work with it. And actually, I just realized that this also, these other objects, email and password, need to do the same thing. So here's, well, email. Oh, that's player roles. Password needs to also be serialized and deserialized. So everything within your object has to be serializable and deserializable for it to work with the database. So that should be good. Let's just run a build real quick. Make sure everything's working out so far. Should be okay. This will also pull in those various packages that we just put into the cargo.toml. So while that's running, crack times, a trait deserialize is not implemented for crack times. Oh, yeah, we got to refactor some things because I almost forgot about that. So crack times, I was storing the whole crack times object in here, but actually when we do this crack times thing here, we're getting back the that's getting back that crack times score. What we really want to do is go crack times number of guesses, and the number of guesses is actually a U64, and the same thing with estimate for score, which is a U8. That should be okay. So instead of crack times up here, what we want to do is put in a U64 and U64, and then we've got crack times dot guesses and crack times here dot guesses, because crack times isn't a serializable object, and so we really don't want to stave that kind of object in there anyway. We just want to know how many guesses it requires. So let's try to build it again, make sure that that came out okay. email, expected ampersand string, found player email. That's probably because I didn't change something in main yet. Yes, there's this. So I'm just going to get rid of this code because we're not going to use it. This was just experimental code to test things out. So I'm just going to delete all this, and that's fine. And let's compile again. Just make sure we get a clean compile. Looks like it's going to work this time, and it did. Okay, so we can close main. We'll come back to main later. Okay, so that's all squared away, and now what we need to do under our player account is we need to implement a trait. Okay, a trait is sort of like an interface. It can contain contracts for how to call something, but it can also contain some code. And when you implement it, you need to implement certain functions. And this is how you implement a trait. I'm going to paste this in here, then I'll explain it. So we're going to implement the trait entity, which comes from reindeer. It's reindeer entity. It's a public trait, and it has a variety of functions on it, and some of them we have to implement. And the three that we have to implement ourselves are the store name, which in this case is player accounts. That's what we're storing. And we're implementing this for player account. So it's for that object. And then we have to have a get key and a set key here, which is our ID. And this should all be good now. We have our entity. But there are some things about this. There's some functions on this now, on this player account, that we can't access from outside the current module. And one of those that's very important is our register. So what we're going to do is create this init function in here. And I'll explain this in a second. This is just what we call a non-associated function. It's a member of the structure, but you don't call it on instances, you call it on the structure. So from the perspective of C++ or C# or these other languages, this would be like a static method in those classes. But it's called a non-associated function. It does not have the self on here, the same as this one. The new doesn't have the self on here. But we're going to do some others that will have the self on here in shortly. We'll build those out. But this self.register is important because only register on this object can only be called from within this module, and we need to register all of our objects. So how are we going to do that? Go back. Let me take a look at my notes just to make sure. We're going to go to our main library file here, and I'm going to create kind of a top-level function that's called init entities. And we're going to put this in a module within here. So the module is init entities, and this is going to be the init all function that we're going to call. And we notice here it says player account init db and expect. So we're going to do this for the player account. We'll also put any other entities that we're going to register will all be in here, so they'll be registered with the DB when it starts up. And how are we going to call that? Well, we're going to call that from main. And so the way we're going to do that in main, and I'll just, I can't put this whole thing in here, but I'll show it to you. The way we're going to call it in main is we're going to use go ahead and use the client. I probably should use the server because this is all server related, but we'll just use the client for now as a way to do this. So let's put this in here. Oops, and we wanted none. And we'll just leave that as a to-do. Oops. So what we will do then is call init all from here and actually we need to capture that, and we'll need to capture the init entities module there. And this should actually build now, I think. What didn't it like? Oh, because I didn't close this off. There we go. Oops. There we go. Let's see if it builds now. I believe it should. It looks like it's going to. Yeah, it built. So we'll do something like this in our server code that will call that initDB function, and that will go through and initialize. Oops, where is it? Lib.rs. So this will go through and initialize our database for all of our, or register them basically. We call init all. We call init on each of those objects. And if we go in here, the init calls self.register and passes in the DB, reference to the DB. And that's all there is to that. So that's kind of set up. We can actually initialize the database now. And we will call that database up here in the main function and pass it as a reference down into whatever we need to have be using it. So let's go back to player, in the wrong folder. And then there's some queries that we can do on this. So I have to find, that's email. Here's player. And I wrote a bunch of functions. We've got that one, get nickname, get email, get player, add token, and authenticate. So here in our player account implementation, not in the entity in the implementation, but here in the player account implementation, we're going to put some functions in here. Paste these in, and I'll go through and explain them. So we've got our init, and then we've got function all, which takes in a database and just returns get all from player account. So this will just return a list of all, actually a vector on a result of all accounts. Okay, and this get all is what returns the result vector of self. Okay, so that's just a quick handle to get into this get all because it's not accessible from outside. Store, you notice we have an ampersand self, so this is an associated function, meaning you're going to call it on an instance of somebody's account and call store, and this will just call self.save and pass in the DB, and it'll save the object in the database, and it works great. Get nickname is just a helper function because our actual data here, these are all private. So even if this is public, you can't access these individual names. We're going to control access to them. They're private things. We don't want outside things stepping on them, writing to them, or whatever. We always want to go through a function. So get nickname will return the nickname and return it to owned. So we get a string back. Doesn't affect the nickname. We're getting essentially a copy of it. And it's therefore immutable. We can't just change the record using it. That makes it very safe and avoids shared mutable state, which is something that's very important to avoid. Same with get email. The only difference here, we need to match on the email, and we need to match on the various types it can be and get that email. And this will actually return the string email. We're going to have another one later that's going to tell us whether it's verified or validated and so forth, because that's going to be an important rule for using the email. Get the player. Again, this is, and we're going to pass in an email as the thing to look up, because that's the most likely thing we're going to know is their email. They type their email to log in. We're going to use the email to look it up. It's going to go through with a filter. And so this is calling player account get with filter. This is one of the functions. These functions, by the way, up here, save, get all. We get these via this entity implementation that we created. We get them for free. All we have to do is implement these, and the rest of it's implemented for us. So same with save. It's one that we get for free from there. So when we want to get a particular player, we're calling get with filter. Now the filter that we pass in is, in Rust it's called a closure. In other languages they're called lambdas. We're basically making a function here and passing it in. And when a get with filter uses this function, it's going to pass in a player account, and we're going to return a boolean as to whether that's one we want or not, and it's whether the account.email.compare to this email is true. It's going to return that one that it returns true on, and it's going to return it as a vector because there could be more than one match potentially. Now, not in our case, but in many cases this returns multiple items. We only want one. We could wrap this up and check for one and return a single one, and we may do that in the future, but I chose to keep it simple for explanation purposes, and we'll just get a vector, hopefully with only one account in it. If we get multiple accounts on the same email address, that's a problem. Although it's possible we might allow that. I was thinking we might allow a 2 account per email address, where one account is a bot account, where a bot can legitimately run on our server as long as it obeys the bot rules. And we'll talk about that as we move through the system and start actually putting it together. So adding a token. This receives a mutable reference to itself, which means that this function can modify the actual record. And you notice we're doing a save here. And so what this is going to do is take in a token that's a string, and it's going to save that token into the token field as some token.toOwned. It's going to grab the ownership of it, and then we're going to call self.save on the DB that's passed in. We're always going to have to pass in a database on these operations, so the token is saved. And then when they come back and they put the token in, they put in their email, they put in their password, it says, you haven't been validated yet or verified yet. You need to enter your token. They enter their token. It looks it up. It says, yep, that's the correct token. Verifies the email address, and now they can log into the system. Until the email address is verified, they won't be able to log in. And then we have an authentication method. So I'll go through this fairly carefully. We authenticate with our database and an email address and a password as a string. So this is what they actually typed in. So we're going to come down here and do an account. We're going to get a result of vector of player accounts. We're going to call player account get with filter. And we're going to look up the player account and compare the email addresses just like we did before. And what we get back, we're going to check it against this pattern. And the one we're mostly interested in is okay. Later, we'll deal with error conditions. I didn't want to overcomplicate the code for explanation purposes, but we should be handling an error situation down here. Right now, I'm just returning a true or false. And so if it doesn't come back okay, it doesn't find an account, it's going to return false, and the user can't log in. We may do something with logging on error conditions and other things later. But I wanted to keep this as simple as possible. So we're going to match on this account that comes back, and if it's okay, we're going to get the list of players. And it should only be one. And it should be, if the length is greater than 0, meaning we got one back, then we're going to look at players sub-0. We're just going to look at the first one. Later, we'll check if there's more than one account. That way we can let bots connect and so forth. But for now, we'll just keep it simple. We'll get that one player out of that reference here. And then we'll take a look and we'll match that reference as a reference to the player.password. We're going to match it with the hashed string. We don't care about the other data that's in there right now. and we're going to do a bcrypt verify password and the hash. And that will return a true or false, and that's what we're going to return from here is a true or false based on this. If it returns false, then the password was wrong. Then we're not going to let them log in. If it returns true, then the password matched the hash, and we'll be able to come in. And so that should do it. Yeah, we're running a little bit long here. Let me build this real quick and see method not found in email. Compare. Okay, I think I forgot to do something important here. Method not found in email. Compare. So let's go to here. Yeah, compare email. Oh, yeah. Okay. Email. Let me look it up here. I did make one modification. Yep. Under email, I have this compare method. We'll get through this real quick here. And so here in player, we come up here to our email. There's password. Here's email. There's validate. There's verify. There's process. And here is compare. So compare gets back, the self, which is some email with that's under this, and a string to compare to. And it pattern matches on self, and if it's raw, it compares it, or if it's validated, it compares it. This breaks it down into actual strings, or in this case, references to strings, so that it can compare them and return it. So that should fix that, and we can now match on emails, and it does. So one last quick thing to do is go over here to main and get our main Rusty Mud. We want the client, source, main, and now we'll just go to here and get the whole thing. And I'll go to main, and I'm just going to paste this whole thing in here and describe it real quick. So basically, this is just a test. We're going to initialize our database. We're going to authenticate a user. And I believe I already have this user in there. So let's just run it. Let's just go cargo run. Cargo run minus bin. Rusty Mud client. And it doesn't like something again. We'll fix this real quick. Main. Oh, I never created the send verification email. So what we'll do is we'll take this out for now. Let's see if that builds. Init entities self. What? Oh, we don't have the email thing yet. There it is. And we see here that it actually saved and pulled back the entity that I created. This is the output from the database. And if we look at go in here to my home folder on Windows, which is going to be users here. I'll bring this over here. We have a .pqr Rusty Mud DB. There it is in the home directory, and here's the database files it created. It manages all that for us, saving the data. And yeah, there's our account setup. So That's going to be it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.